Right. So what we discussed in the last session about uh,
12 factors.
12 factors and all, everything were discussed. After that, I'm going to discuss today about what are the different scenarios we need to define whenever we are working on microservices, especially whenever we are designing those, because designing levels are designing the microservices is what we have to perform. If you want to perform designing level for microservices where there are different scenarios we need to be discussed with. So prior to that, I would like to ask you, like, you have a knowledge over SOA, right? Service oriented architecture on that. Right. So do you have that?
Yes,
Or,
little bit.
right. Okay. Right. So once this is done, so I'll be explaining about how different service oriented architecture with microservices. Okay, so that part we'll be
Okay.
discuss it later. Let me discuss about what are the different scenarios which will be defined when it comes to the designing of microservices. Normally, these designing of microservices will be categorized in these areas because these are the scenarios we have to be known with. Because unless until these scenarios we don't understand, or these scenarios we don't implement, so quality of microservice implementation is not something practically viable. Okay, this is where the point was. Now there are different scenarios. The first one is called autonomous functions. So autonomous functions where whatever the functions which are under review must be autonomous in terms of implementation itself is concerned. But whenever we are working on microservices, whatever the autonomous functions we are implementing must be taken into consideration within the boundaries of the microservices. But whereas when it comes to the size of deployable unit, whereas the second one is of size of deployable unit. And whenever there are microservices we are using on, these microservices must ensure size of the deployable units must be manageable enough. Because if we doesn't have a clarity over the size of deployable units, because deployment we do depends on the functionalities whatever we have developed so far, right? So because this deployment either it may varies from the regular traditional application development model versus the DevOps environment. Because when it comes to the deployment in reference to the DevOps environment, wherein we need to create a pipeline, so which is for CA and CD part, right? So continuous integration and deployment, for that generally we have to create pipeline. So whenever we are creating deployment units and all everything, these deployable units must be in a size where it can be easily deployable when and wherever it is needed, so that we don't find any difficulty in deploying it either in the client systems or something like. The third one about polyglot architecture, whatever the modules, right? So different modules, whatever are required for us to for a different architectures and all everything for different technologies. Polyglot architecture will differ from the kind of modules whatever we required. So for every module and all that, so different architectures and will be used here. Next one about selective scaling, wherein whatever the functionalities we are working or implementing and all everything, so these must be within the boundaries of the scalable requirements, whatever we are implementing. I can give you like selective scaling means, let's say, for example, for example, we are uh, uh, we are we are booking for a for vacation. Like for example, we are booking for a vacation wherein we are booking for a hotel booking or something like that. So we are booking a reservation for vacation, all that. Generally, whatever the microservices we are searching for, this must be, this has to uh, scale considerably more than the booking services, whatever we have implemented. So whenever we are trying to understand about the scaling part in reference to the implementation, as far as the scenario is concerned, while we are designing, so that must be scalable enough where we have to identify for what purpose and for what reason we are implementing this. This is where generally selective scaling come into picture. Next one about small and agile teams. Because as we all know, whenever we are transforming nowadays from the traditional approaches to agile environment, it is always important for us to understand about what are the different agile teams are we implementing. Because as much as less agile teams we have more advantage. That is where this situation was. Because small agile teams has an advantage where proper coordination is possible because we conduct regular meetings with the team members so that we will be knowing about the progress of the work. Of course, that will be done in the Scrum Master level, like, because Scrum Masters has to review. So what was the work they are implementing all that. So whenever there is a small agile teams work, like either it can be implementation, either it can be Scrum or Kanban, because we have two different things. One, uh, as far as the teams is concerned, whenever we are focusing on Scrum framework is entirely different than Kanban model. Because whenever we follow Scrum framework, especially in Agile, it is more like whatever the sprint developments is what we do. Because whatever the sprint developments we do, everything will be done in the Scrum level. At the same time, whenever we talk about the team size, especially in Agile, when we follow Scrum frameworks and all, usually it will be varying somewhere around 8 to 10 people we have. But whereas when it comes to the Kanban, it was not the case, because Kanban is a model where uh, there won't be any rules as specific like we see like product owner, right? So there won't be any rules of that, because Kanban is uh, completely a Kanban team, right? So because whoever is implementing, designing, right? So all these people will comes under the Kanban model itself. But whereas when it comes to Scrum itself is concerned, it was not the case, because Scrum have multiple different roles. But end of the day, limiting in the team will enable people to understand an effectiveness over implementation of microservice designs. Because whenever we are transforming from the traditional developments to the new applications, it's always important for us to understand, at the same time make sure each and every person, whoever is working on agile environment, should have an understanding over the difference of architecture from monolithic to microservices at the time of design level. I'm talking about that, because I don't say that uh, architecture will be involved by 100% all the people, but at the sort of design level, people who are especially working on agile environment should have an awareness over that. That's the reason it is always important for us to have a scenario if we are less team members. Less team members is possible in agile, whereas when we follow the traditional approaches and all, team size will be of different. Is it clear to you, Aishwarya? Understood,
Yes.
right? So because team size will be less in terms of agile is concerned, but whereas when you are comparing with the traditional model, the team size may vary, right? So it may go up to 15, 20, more than that sometimes. Of course, irrespective of the hierarchy, whatever we follow. But whereas in agile, the advantage is that the team size is very limited. When the team size is very limited, it is always possible for us to address the limited people, and focus will also be on the limited people, as well as whenever we are working on the design level in reference to the microservices and all, understanding the scenarios will be much easier for them. So that's the reason why we always give preference to the small and agile teams, all that. Next one about single responsibility. When it comes to the single responsibility itself is concerned, normally when it comes to the microservices implementation itself is concerned, uh, it cannot be shared with multiple microservices, whatever the responsibilities we are implementing on. So because single responsibility will be given for a single microservices, whatever we have taken, because the kind of principal practices we are following to design the microservices, something confined majorly for every component. Every component level implementations will be taken place. So single responsibility as far as the implementation is concerned will be confined only to a single microservices. This is not something related with other microservices also, because we have multiple microservices for every components we are developing. Single responsibility for single microservices is the major point we need to be focused. Next one about replicability or changeability. Whenever there are microservices boundaries we have identified, it must be in such a way like whatever the microservices are we using must be uh, easily detachable from the overall system. That is what is required, because this is the fundamental point. I think you understood this, because this is where generally the difference we see from monolithic approach to microservices. Because when it
Yes,
comes to
yes.
the monolithic approach, it is tightly coupled, where decomposition of components might be difficult, because whatever the testing you want to run, everything you have to run it from the basics. That's how it is. But whereas in microservices, the major reason why we are going for microservices was because of that. Because earlier requirements in reference to the functionalities which customer used to provide was different, because there used to be a standard and static requirements we used to. Static, it's not static, standard requirements. There won't be much volatility. But nowadays it is different. I'm not specifying this for a particular industry or a particular domain. This can be for any of the domains, right? So irrespective of the domains, whatever are we using, whenever we are working on 1 minute, Aishwarya, just be online for it.
Okay. Okay.
Sorry, I've got a call. Disconnected.
No
Thank you.
problem.
Right. So yeah. So now yeah, right. So when it comes to the overall microservices, where there is a this is where generally, because each and every component we are developing, because this is not something I'm specifying for a particular domain, because it is not something connected with the domain, but depends on the business functionality what customer is performing, because depends on the customer what is that they are performing, whatever the implementation of uh, architecture we are developing must be flexible enough to make necessary changes into that. So that's how the situation was changed over a period of time. So that's the reason why even agile DevOps, each and every implementation, why are we doing? Due to that reason only. Because earlier there is a standard structure of implementation used to be taken place. So once the implementation done, the next we used to go for deployment. That's how the earlier situation. But when there are any changes to be made into the existing functionalities, again, you have to perform this activity from the scratch. The reason, of course, we are using different tools like Jenkins, Kubernetes, all that. So we are using in Jenkins DevOps environment so that we can streamline the process and we can create a pipeline for continuous integration and deployment so that we don't see any difficulty in it. So adoption of DevOps we are doing nowadays for implementing our applications due to one reason, that because of that reason. And second reason, implementation of Agile or adoption of Agile we are doing due to the reason of short-term deliveries, because earlier we used to have delivery of the piece of work, even though sometimes piece of work sometime will be in months' time, right? That's how the situation earlier was. But nowadays, the situation has been changed in such a way where whatever the implementations we want to do and whatever the deployments are we doing, everything will be sometime in months, right? So that's how then generally the situation has been changed. So this scenario is something relating to that part, right? So this is one thing which we need to be understood when it comes to the microservices part itself is concerned, because scenario understanding about the scenarios were something essentially important, because whenever we are implementing the microservices architecture, this is something which is very important for us to understand. Next one about coupling and cohesion. When it comes to the coupling and all, whatever the interdependencies we identify between the modules, whatever we are developing, because there will be an interconnectivity or interdependency among the modules whenever we are developing an application. At the same time, when it comes to the cohesion part, which majorly uh, trying to understand about how these are related in terms of the functionalities in a single module, right? So this is where generally whenever we are creating this high level and as well as low level diagrams and all everything, so these detailings and all everything we explain, because the micro level understanding over the functionalities when we are developing is essentially important and should be understandable to the technical team. That's what we have to do. So we need to understand the interdependencies as well as interconnectivities of the modules, whatever we are implementing. At the same time, it is equally important for us to understand about the relations over the functionalities within a single module and how these are impacting while we are making any changes in further, right? So this sort of understanding and this set of scenarios should also be considered. So always important for us to have a clear understanding over high level designs and low level designs. Then most of these problems, whatever the problems we may be facing while we are implementing microservices architectures and all, designing microservices for all the components will be much easier. But make sure we need to have a complete understanding over the high level as well as the low level designs. So if you have that, so this will be much easier for us, so that when there is an implementation we don't see any difficulty in using it. So these are the different scenarios which we have to be considered whenever we are designing the microservices, especially either it can be a component level, whatever we are working on that. Is it clear to you, Aishwarya?
Yes.
Okay. Now, after scenarios, the next thing we need to discuss about the communication styles. So after that, I'll go to SOA, because communication styles are also important in microservices. So let me explain this. Then I'll get into service-oriented architecture possible today. Tomorrow I will discuss about that. Now, when it comes to the communication styles and all, normally communication styles will be categorized into two different parts. So one is about synchronous styles and second was asynchronous styles. Because communication between the microservices, whatever are we going to design, must be of two things. One is about synchronous one and second was asynchronous. Synchronous style where we request response. This is the aspect will be taken into synchronous style. But whereas asynchronous style itself is concerned, fire and forget, right? So these are the two different styles which normally we see. This is where generally the synchronous style was. And second, this is where generally asynchronous style was. But when it comes to the synchronous style, where whatever the communication we are doing, especially in this style, communication style, there is no there is no standard. There is no standard state or queue which normally we maintain. Because, for example, when a caller has requested a service, right? So it passes the required information and wait for a responses, right? So that's where generally the synchronous style majorly useful whenever we are building microservices architectures and all. So major the advantage you see, especially in synchronous style, is that there is no messaging server aspect as well, because whenever there is a request, caller as request as a services and all, usually it passes the information and wait for the responses, so that there is no messaging server overheads or something like, right? So there is nothing of that sort. At the same time, if there is anything of that sort, right, any corrections to be made, the whatever the errors we have identified will be propagated back to the caller immediately, so that necessary corrections can be done accordingly. This is where generally the major advantage we see when it comes to the synchronous styles and all everything. But whereas when it comes to the disadvantages in terms of the synchronous style is concerned, the caller has to wait until the requested process gets completed, because till the time, because the waiting period, whatever the waiting period, whichever is taking, especially in reference to the responses they were going to get, will be of more sometimes, where since till the time the caller has to wait until the request process gets completed, right? So maybe that will be taken some amount of time for us to complete. This is one advantage, but I don't say this is one disadvantage all the time. That depends on the complexity of a particular particular service which we are implementing. So this will be varied on that. At the same time, it is difficult for us to add dependencies between the microservices. Like for example, one service, each and every services, whatever we have taken. So that's connectivity of these services change, fails and all that. So the complete structure of chain system will also be broken, right? So broken. There is a possibility of uh, there is a possibility in this style of synchronous style, right? So this is where generally the disadvantage we see whenever we are implementing that. Now, whereas when it comes to the asynchronous style itself is concerned, whenever there is a service we have designed to accept any synchronous messages as an input we have taken, sender has to send a response asynchronously for others to consume. Because whenever there is a asynchronous style, it's being used, that's based on the reactive events, whatever we are implementing, which are decoupled microservices, which are implementing in different parts of the components, whatever we are using. Because the advantage, especially in reference to the asynchronous styles, are whatever the microservices we are implementing were decoupled, right? So they're not tightly coupled. So that major advantage was that. So that whenever there is change we want to make, or whenever we want to make any changes for the particular component, can be done easily, so that we don't find any difficulty in doing that. So we don't, because amount of time whatever we are spending in reference to the implementation itself is concerned, will also be much lesser. At the same time, higher level of scalability will also be more, right? So because of the higher level scalability, because the services whatever we are implementing were independent. So when the services are independent on its nature, when we are implementing, there will be a possibility where the higher level of scalability, whenever we are implementing this in various levels of business, whenever we are implementing, so scalability will be more, because the services are uh, independent. These are all not dependent. So these are the advantages we see when it comes to the asynchronous style itself is concerned. But whereas when it comes to the disadvantages itself is concerned, especially in an asynchronous style, where it has a dependency with an external messaging servers. Because whereas when you see in synchronous style, we don't have it, because whenever the waiting responses or messaging responses won't be taken much time, right? So we don't wait for that. But whereas when it comes to asynchronous style itself is concerned, whatever the dependencies to an external messaging servers will be more, so that the waiting time will be more, right? So that is one of the disadvantage we can see here. At the same time, we are implementing this asynchronous style approach in reference to the communication style itself is concerned. It will be difficult. I don't say difficult to sometimes it will be difficult. I don't say 100%. It will be complex even to handle because the fault tolerances, because when there are any changes happen on a particular component, uh, the application has to run as usual, right? So because it won't get affected because of the changes, whatever are we making, all that. So handling this sort of fault tolerances is difficult when we are working on the uh, asynchronous style of communication is. So these are the two different communication styles which normally we follow whenever we are working on the microservices, whenever we are implementing. Is it clear to you, Aishwarya? Understood?
Yes. Yes.
Right. So these are the things we need to know, right? One is about what are the scenarios to be taken into consideration when we want to design microservices. So the points were that. So followed by this and communications.
I have a question here.
Please go ahead.
Like for